So the following slide will represent the iterative design process, including the different phases of defining the problem, generate concepts, develop a solution, construct and test a prototype, evaluate the solution, and finally present the solution. So as you can see here, it's clear that it's an iterative process because each time you might go back to the initial state and we'll see what, okay? So this is why the design process is very challenging and might need to do redesign sometimes, but at the end we will be able to reach the desired level of our design. So now we will describe each phase step by step. So to start with, we said that the main part first is to define the problem. So we should identify the problem, and also we should ask ourselves if it's really the problem or not. So this is what we call validation of the problem. So first, who says it's a problem? So it's really a problem or not? And what are the needs and wants? So when we know the needs and wants, we can define really the problem. So it's a step to go through the definition of the problem. And we can try to look for prior solutions. Now, another step, important step in the definition of the problem is to justify it. What do we mean by this? So is this problem worth solving? So of course, you might have a lot of problems, but solving a problem might be of very high cost. So you say, no, okay, I can survive with these problems. No need to solve it. So this is also, this can be, for example, of economical aspect. Or maybe the problem is not worth of solving. I mean, it's not affecting, let's say, other components, and it's not affecting safety or important issues, so I can survive with it. It's fine. Now, once this is done, okay, I also have to know what are the design requirements, what are the specifications needed to have a clear definition of my problem. So I can go to codes, I can go to standards to know what are the criteria and constraints in my design. So now, even sometimes when going through the definition of problem, in some cases you can start with a definition, but you might find that it's not valid or not justifiable. So you can design, you can go to a new definition maybe, or say, no, I can survive with it and I can skip the solution of this problem. Okay. Now, once you are done with this step, before moving to the other step, you can do a brief design, because this will be like a small plan, okay, that will help you into continuing your process. So the brief design can be through writing a plan that identifies the problem to be solved, what are its criteria and constraints, and it will encourage your thinking of all aspects of the problem before attempting the solution. So this brainstorming will help you a lot in the future stages. Now, once the first step is done, we can move to generation of concepts. Here also we have different ideas. We can say no need to do research or gather information. We directly start to propose solutions. But as I told you, it's not advisable, because this is a step of research will help you a lot after and will save your time in the majority of cases. So when we talk about generation of concepts, we should do some research, some literature review, what other researchers have done before in the same field, what were their conclusions, what were the solutions they suggested, are their problem comparable to our problem, or what is the idea that we can benefit, what is the conclusion that can help us into our design. We can do also a brainstorm for possible solutions. So we will give our ideas, or we might think about possible solutions that can be done. Plus, we will set the design goals. So when we know what are clearly our goals, this will help us into the our design. And of course, we should select an approach to follow. Okay, each time when we want to put a plan, we should select the approach. Is it a programming way? Is it using a certain software, etc. And a very important step is to put the decision matrix. And we'll see together now what do we mean by this decision matrix. So the decision matrix consists of a tool used to compare design solutions against one another using specific criteria. Example, let's say we have a certain problem. So going back to our initial problem, let's say we need to ensure good indoor air quality in the space because of safety issues for corona, for example. And we say that the conventional system used, which is mixed ventilation, is not very appropriate because what is mixed ventilation? If you have a, let's say, a room, in mixed ventilation, you have an inlet and you will circulate your air. So as the name indicates, it's mixing inside the space. So air will be mixed inside the space and then it will be exhausted from the space. In this way, you can remove the thermal loads, but at the same time, this is risky for indoor air quality because it can transport. Let's say you have two occupants here, and one is generating contaminants. Because of this mixing action and turbulence level, the viruses can be easily transmitted to the other occupant, which is bad. So let's say we want to come up with new ideas. So we can say that let us replace this system or maybe assist it with new systems. For example, one idea will be to use personalized ventilation. What is personalized ventilation? So for each person, I can put in front of it a small device that will give it a small amount of fresh air, okay? And in this way, we can first reduce a lot the energy consumption because in mixing ventilation, you are cooling the whole space. And also you are trying to, if you want to have very good indoor air quality, you need to increase a lot the proportion of fresh air entering. And you know that fresh air, the higher the proportion of fresh air is, then the cost will increase because when you recirculate air, the cost of cooling is lower than the cost of cooling air that's coming from outside. Because when you recirculate air, already the temperature of air is relatively low, so it will not take you a lot of energy to cool it to, let's say, 14 degrees if you want to enter it at 14. And the temperature of the room is, let's say, 24, for example, okay? You have only a difference of 10 degrees. While if you want fresh air from outside, let's say you have a temperature of 35 outside, then you should cool from 35 to 14, which is on the cost level, it's very high. So to be able to reduce this percentage of fresh air introduced, we can assist this system with personalized ventilation, which will provide the occupant directly with fresh air. And therefore, I need a lower amount. And also, I can ensure localized comfort. So I can maintain a higher temperature in the space, while in the microenvironment of the occupant, I have an acceptable level of comfort. So this is a very good strategy. It will save energy, it will ensure comfort, and it will enhance the air quality. For example, now I should assess different factors that will help me into the selection of the solution. So first, I should study the cost and the complexity of installation. So maybe it's not easy to implement it with mixed ventilation. So I should test this. I should look at the time needed to install the system. So if it's a very long time, maybe I would say, no, I don't want to go for this solution. So I can put a certain scale, if you want, to grade the different ideas, okay? And then find the total. So I can use a grading criteria, let's say from 0 to 5. 0 is the worst, 5 is the best. So I can do it on my own. I will do it for all factors. And also you might use weights. And maybe cost for you is more important than the developed time. So you can use higher weight for cost than for the time. Or if time is your primary goal to have a short time, you might have a higher weight for time. So everything depends on what you want. So at the end, when you assess the different ideas, you will have a total grade. So you can select the one which will have the highest grade will be selected, let's say. Okay. So for example, if you want to advise to use something else, we can say, why not to change the system of ventilation? So instead of implementing something with it, maybe we can say maybe displacement ventilation is better. In general, displacement ventilation is better for air quality in some cases because it will provide fresh air from low level, and then the exit is at high level, so it can help into transport of contaminations. So you can study it, okay, by simulating the case by CFD. And you can propose many other strategies. You can use filters. So always you can have several solutions. And then you should study them to be able to select the best solution. Okay.
Doctor,
Yes?
the mixed ventilation, it means the natural air plus mechanical systems.
Displacement. Can you
ل-
repeat, please?
yes,
I didn't hear first.
mixed ventilation.
Can you
It
please write
means
it? Can you please write it in the chat? Because I'm not hearing you well. Yeah, I will check the chat. Okay, when it will be done, let me know, okay? Okay. Mixed ventilation and mixing ventilation is the same. Okay, Joseph, it's the same name. So some researchers call it mixed ventilation, others call it mixing ventilation. So in this case, yes. So in this case, in mixed ventilation, the concept is to take a portion of a natural or fresh air, okay, plus a proportion of recirculated air, and this is to reduce the energy consumption, and you will cool it to a certain temperature, then reintroduce it into the space. And of course, you will use a mechanical system. Okay, and this is in general the conventional mechanical system, the HVAC systems you use. Yani all conventional HVAC system are based on mixed ventilation. Okay, is it clear? Okay. Now, so as we said, in the phase of generating concept, okay, we can sometimes have a technology that is required to develop the solution that does not exist in literature. So in this case, we need to develop scientific research to come up with a solution. So sometimes we should do hard research work to be able to find a solution that can tackle our problem. So this is why the research and gathering of data is very important. So it will help you to stay consistent with working criteria while you are doing your research. So one, how to perform the research. So when you want to perform a research, you should make sure that the information you are gathering is consistent with the working criteria you selected. Okay, so these working criteria were done in the first phase, because when you defined your problem, you have set what are your working criteria. And this will help you into, after when you do the literature review, this will give you the keywords if you want to your work. So when you are searching, you will try to find work that have the same goals or same criteria. And this can be done using resources, several resources. So you can, to do your research, you can use the internet, the library, newspaper, journal papers in general are very helpful. Okay, because journal paper are concise and they implement very important information. And you should keep info found through all steps of the design process and add to it. The research phase sometimes is not restricted to this phase, because whenever you proceed, you might find that you need to go and research for new things. And as we said, this is normal because our design process is always iterative. So sometimes when we do a scientific research, we might reconsider the problem, the definition of our problem. So we can go back to the first step. So we can go back to zero and say, no, maybe I should change this in the definition of my problem, or I can change it completely. So depending on the case. Now, I want to develop a solution. Once I generated the concept and I am done with the step, I will move to developing the solution. So I want to create a detailed design solution. And of course, I should justify my solution path. Okay, so sometimes I can suggest a solution, but it cannot be justifiable. So maybe on the economical level or maybe on the safety level, etc. So once I justify the solution path, I can move to the step of technical drawings. And what we mean by technical drawings is this is the drawings that provide technical information that is required to come up with the final product. So for example, what is the material to use? What is the size? What is the shape? Do I need to perform assembly if required, etc. So for example, you can see here in the following slide, technical drawings for the design of a car. I should give sketches for the different parts, for profile view, for top view. I can perform a 3D representation. Of course, when we deal with cars, you will use complex softwares. You can do the representation in 3D. And in the next step, you will test it. You will test it, let's say, by computational fluid dynamics to see what are the lift forces acting on it, what are the drag forces. You can optimize the design of the curvature. The curvature of a car affects a lot its performance, okay? And it's a very important factor in the design of cars. So you can see the advancement in technology of cars by comparing the profile of cars in with time. So initial cars were like this, and this is very bad for drag, okay? And as they were evolving, you start to see curvature, you start to see the implementation of spoilers, you start to see mirrors in a nice shape, etc. All of these are not only to have a beautiful car, but also it will help you into reducing the drag on your car and having a better performance of your car. Now, once the previous step is done, we can now develop a solution. So we will start to think not only about one solution, as we said, we can try to find several solutions, because as we said, a solution might be invalid or cannot be justified. So the designer will return to a previous step in the design process. And again, we can see the iterative behavior of the design. Now, once we develop solutions, okay, and we select based on our decision matrix, we selected the optimal solution. Now we are ready to move to the next step. we will construct and test the prototype. Okay, so what is a prototype? Prototyping is the first stage of testing and implementation of a new product. And it consists of building a prototype of the product, which is the first fully operational production of the complete design solution. A prototype is not fully tested and may not work or operate as intended or desired. So the purpose of the prototype is to test the design solution under real conditions. So for example, let us say you are designing a new car, okay? Sometimes you will not directly, of course, do the final product of your car. You will first construct a prototype, and the dimensions of prototype do not have to be the same dimensions of your car, of course. You know, in fluid dynamics, you have taken a full chapter about models and prototypes. So you can construct a small prototype, but you have several conditions to satisfy to be able to extend your results to the actual model. So if you remember from fluids, the condition is to have the same dimensionless number. So we have same Reynolds, let's say. So we study the problem. We consider what are the dimensionless group involved. Let's say the Reynolds number, the Mach number, etc. And we determine what should be the geometrical parameters of this car in order to satisfy even, of course, not only the geometrical parameter. Let's say you are doing a wind tunnel experiment or test on your prototype. You have air, let's say, flowing at a certain velocity v. Even you can use a different fluid. So in reality, it's air. You can in the experiment use water, for example. The only condition is to have similarity. So if you remember the chapter of similarity and groups in fluid mechanics, this is its application here. You can apply it in your design process. So whenever you determine what are the dimensions I can take for my prototype and what are the conditions in my wind tunnel experiment that are similar to the real case scenario, then you can construct your prototype and you will perform several testings and experiments on it before producing your final car. So once you construct your prototype, you should check its performance, usability, durability, and once your prototype is ready, you will test it. You will collect test data and by doing several experimental work, and then you will do analysis of your data. To maybe from this analysis, you will say, I cannot go now to the final stage directly. I should change something in my design. Let's say to enhance maybe the performance of my car or to have higher speeds of my car, etc. And once you are done, you should perform a complete report on your observations, because these reports will be used to construct design charts. So for example, you know that for any car at the end, you have design charts for it. They will tell you how it will perform. They will completely describe it for you. So this is an example of testing. So here, this is a picture of aircraft wind tunnel test. So for example, here, our wind tunnel is really large. So this can be, this is a very advanced prototype. Okay, so it might be in the late stages of testing. And of course, you have this in several applications in car design. So here you can see in prototype from wood, a prototype from wood performed, because you know the cost. You know, you should, when you do a prototype, you should pay attention for the cost. So always in the first prototyping stages, I try to use a small cost prototype. And as I advance, I can move to more complex and the higher cost for my prototypes, because I will be sure that I am close to the final design. So if a testable prototype cannot be built, or test data analysis indicates that we have a certain problem in the design, again, as we said, we should return to the previous step of the design process. This is why I told you for the first prototype, don't put a lot of cost because you might have to redo everything. Now, once we are done, we will be ready to evaluate our solution. We will evaluate the solution effectiveness. We will do some reflections on the design, and we can recommend some improvements. So even if the solution is working, we might have some other suggestions to improve it, or we might do some optimization and some redesign to reach better performance. So this is always under the idea of iterative design process. And once we are done, we can write our project recommendations. Sometimes you might reach a solution, but you can say, I can suggest future work. Okay, so always things can be developed. You cannot maybe in one design reach all the goals you want, but it will be good to write your recommendations for any future improvement. And of course, in any project you do, the final step will be to present the solution to others. So you might be a very good designer, but if you don't know to communicate your ideas, no one will consider your design and will adopt it. Okay, so a very important step is the final step, which consists on presenting the solution. So you should document your project. You can prepare a project portfolio including all steps of your design. And you should also communicate your project. You can perform a PowerPoint presentation, a formal presentation. You can, let's say, prepare some videos showing the different stage of your design. You can present, of course, your results, why you selected the solution, how the solution was much better compared to other alternatives, etc. Okay. So at the end, you will always, as we said, try to do improvement of your product or redesign it if it's required. Okay. So in summary, these are the detailed steps of the design process. So we will briefly go over them again as a summary. So first we define the problem. We brainstorm possible solutions. Then we start to generate ideas. And we will look at each idea separately. We should analyze it and explore possibilities. Then we should specify the criteria and constraints that will guide us into research. And we will consider different solutions, not only one solution. After this, we should select what is the approach we will use into our project design. We will develop a written design proposal. We will construct a prototype, test it, and evaluate it. And we can always refine it to improve the performance of our final product. And finally, we will communicate our results. So this is an introduction of the design process. I hope that you will enjoy the course. If you need anything, feel free to contact me anytime you want. Any questions before we start? Okay, just for next time, a small homework will be to propose a certain problem in which you will do like a sketch for all steps that should be performed to design a solution for this problem. Okay, I will formulate the problem for you and post it on eLearn. Any questions?
Doctor?
Yes.
Where can we find the records of this session?
I will post all recordings in a YouTube playlist and I will make it available for you.
Okay, thanks.
Doctor, please, can you repeat the homework?
Yes. The homework will be, you will propose a certain engineering problem, like the example we did together, okay? Any problems that you might face, okay? And you will start to to do all the procedure and to go through all steps. So first you should define it. So for example, as we did, let's say in our case, the problem definition was we want to enhance the indoor air quality to reduce contamination in indoor spaces. Okay, this is a definition. Now, in brainstorming possible solutions, you can develop several possible solutions. Okay. Of course, for example, you can do, let's say, a small research when gathering information, but you will not do, of course, the whole process. It will be then a project. What I want from you is just to go through a plan, if you want, and how will be the different steps in your work. So in summary, for each step, what is the plan to go through? And finally, you can, for example, in this stage, let's say, of the alternative, you should propose a decision matrix. What will be the criteria for selection of the solution, etc. And you should put these details. Okay.
Okay, thank you.
Any other question? Okay. So we will discuss your ideas next time. This will help us into developing our techniques in the design process. Thank you. Bye.
Doctor,
Yes.
can I ask about the FYP? Friday, at what time we'll do the meeting?
Yeah. Okay. Yes. Just one second.